Hi, I'm Mr. V. Today's our fourth day of discussing similar triangles. And I'm going to start with some of the work from last week as a review, and we will then talk about the side splitter theorem. So first of all, we were given that the longest side of a triangle similar to this is 13. So if the longest side would match up with this one, I can redraw my triangle here, and this side would be 39. My scale factor going from the small one to the large one is going to be times 3. I did not draw it larger, but not to scale, okay? If this side is x and this side is y, if I scale this up by 3, I get 36. If I scale this other one up by 3, I get 30. And I'm done. And if you don't like doing it that way, you could also set up a proportion. X is to 12 as 39 is to 13. This simplifies to 3 over 1. X is to 12 as 3 is to 1. And when I multiply both sides by 12, I get x is equal to 36. And you could do the same thing for y. From the homework, we are told that the two triangles are similar. And notice BC, the last two letters, matches up with EF. AB and DE, those two and these two match up. And AC matches up with DF. So these are all the sides matching up the way that we've written the proportion. We're to find the scale factor going from this to this one. Notice we're getting larger. So if this were my point of dilation, and I started with this one, which would be ABC, when I go to make it larger, I'm going to scale it up by some factor, and I get a bigger triangle. Okay. My k here is equal to 1. My scale factor has got to be greater than 1 to be getting larger. If it were between 0 and 1, I would be getting smaller. So I start with what I'm going from. That will be the denominator. I have 10 in the denominator, 25, 16 and 40. 16, 40, and I have 50, 20, and 50. And my scale factor is 5/2. That is, what do I multiply triangle ABC sides by in order to get to the larger scale factor? My scale factor is equal to 5 over 2. Okay. Here we're told that the two triangles are similar. Notice they are in a like configuration. Notice that going from 5 to 10 is a scale factor in this direction of times 2. So I go from 11 to this. If I multiply 11 times 2, I get 5x plus 2 is equal to 22. Subtract 2 from both sides, 5x is equal to 20. Divide both sides by 5x is equal to 4. You could have also gone in the reverse direction, in which case this is getting smaller, so it's going to be a scale factor of 1/2. Half of 14 is 7. So if I had written 2x minus 1 is equal to 7, or 2x minus 1 is to 14 as 5 is to 10. Notice this is 1/2. Multiply both sides by 14. I would get 2x minus 1 is equal to 7. Add 1 to both sides. 2x is equal to 8. Divide both sides by 2. X is equal to 4. Same answer as what I had here. This way I'm doing it with setting up a proportion. This way I'm doing it with the scale factor. And I could have done this as scale factor as well, going in reverse. Here we're looking for x. And notice I have a vertical pair. These are congruent. And I have parallel lines. A transversal crosses parallel lines to form congruent alternate interior angles. So I can reconfigure this triangle, which is something I'm asking you to do to be able to set up the proportion correctly. So when I redraw this smaller one here, between the two sides that are marked, the angles that are marked is 3. On the other side is 2x minus 8. So I can set up a proportion. 3 is to 5, small triangle is to large, as 2x minus 8 is to x plus 3. Now, if you do not put grouping symbols here, when you go to cross multiply, you might make a mistake. This is one of the techniques for solving these problems. We can cross multiply to solve a proportion. So I get 3 times x plus 3 is equal to 5 times 2x minus 8. Now I'll distribute. 3x plus 9 is equal to 10x minus 40. And when I subtract 3x from both sides, I get 7x. And I add 40 to both sides, I get 49. And I'll divide both sides by 7 to get x is equal to 7. Nice number. This last one, we're also looking for x. And here I have that triangle QRS is similar to triangle QKL. Well, these are vertical pair. Which other angles are congruent? These don't look parallel, so I'm not going to mark K and S. I'm going to look at angle QRS, this angle, and angle QKL. Oh, this is the butterfly. Remember, I told you the different configurations. We'll call this the butterfly. So if I redraw this triangle, I rotate it to match the configuration here, where the one tick is at the top and the two ticks are at the bottom. Between the two ticks is 11x plus 13, and next to the one tick is 168. So I'm looking for x. I can set up a proportion. I'll put this on the top because I'm looking for the x. I could put it on the bottom and then cross multiply, but I'll just start with it on the top. This is to 65 as 168 is to 70. When we multiply both sides by 65, these two cancel, and I'm left with 11x plus 13 is equal to 156. Subtract 13, 11x is equal to 143, and divide both sides by 11, x is equal to 13. On these type of problems, you want to make sure that you answer the question that is asked. Here we're looking for x. If I'm looking for this entire side, I'd have to plug this back in and then solve for the actual number. That would be one way of doing it. In today's lesson, it's on the side splitter theorem. By the end of the lesson, you will be able to explain why a segment parallel to one side of a triangle divides the other sides proportionally. Notice it does not divide the sides that are parallel, it divides the other sides. And I can use proportional parts to solve problems. So here we had some things to notice and things to wonder. Some kids said, I wonder if this is a midpoint. I wonder if this is a midpoint. Someone said, I notice it's a midpoint. I don't notice that. There's no marking here to indicate that's a midpoint. And notice this is a pair of parallel lines. I notice that B is congruent to itself. I notice that these angles that are corresponding are congruent. I wonder what it means for similarity. And so here, students, you were asked to explain why this divides this into parallel parts. Does a line parallel to one side always create similar triangles? I make a conjecture. The conjecture is a line parallel to one side of a triangle always creates similar triangles. And my reasoning for that is this. If I have parallel lines, corresponding angles are congruent. These two angles are congruent. These two angles are congruent. By the angle triangle similarity theorem, the triangle ABC is similar to triangle MBN. That's my reasoning. Now you were also asked to explain, let's see in the next part of this, here we have a transversal crosses parallel lines to form congruent corresponding angles. So the corresponding angles, its theorem says, if two lines are parallel, then the corresponding angles are congruent. And you could also say that B is congruent to B by the reflexive property, that angle B is congruent to angle B. And so I'm going to show you another way of proving this. We'll do it like this. Here I have two triangles. I'll redraw the triangles like this and like this. And I'm going to say this is equal to B plus A. This is B. And this is equal to C plus D. This is D. Now, I can set up a proportion. A plus B is to B as C plus D is to D. And I can rewrite this. A over B plus B over B is equal to C over D plus D over D. Now this is a 1 and this is a 1. If I subtract 1 from both sides, I get A is to B as C is to D. A is to B as C is to D. Now we know that there's 4 ways of writing a proportion. I could multiply, for instance, both of these sides, by cross multiply it, and I get A times D is equal to C times B. And what I'm looking for is A is to C. So I'll divide both sides by C. This becomes 1. I'll divide both sides by D. So here I have A is to C as B is to D. Proportional parts cut by these parallel lines. This does not have to be a midpoint. If it is a midpoint, then this would be a midpoint as well. But this could be 2 is to 3 as 2 is to 3. Or 4 is to 6 or something else. And with this in mind, we go to solve problems. Let me show you a couple of practice problems. These are ones that you would do on your own. So I'm looking for this side. This side right here is what I'm looking for. If 3 is this much and this is 7, then this small length here is 4.5. And I'll call this distance x. I can write the proportion x is to 4.5 as 4 is to 3. And when you multiply both sides of this equation by 4.5, in order to isolate the variable, get this by itself, you can plug this into a calculator and you get x is equal to 6. That's really annoying, isn't it? Here's one. These sides are parallel. Segment EG is 12. Segment EB is 2.5. Now, if I were to redraw these two triangles, I have 15 is to 5 as 12 is to, we'll call this little thing here x. Notice this is a scale factor going from the one to the other of a 1/3. I'm getting smaller. So 12 times 1/3 is 4. This distance is 4, which means this is 8. Now notice, going from 4 to 8, I'm going up by double. So going up by double from 2.5, I know this is going to be 5. We'll call it y. I could also set up a proportion. Y is to 8 as 2.5 is to 4. When I multiply both sides by 8, I get y is equal to 5. Maybe it's clearer on this one. DB is 24. AE is 3. EC is 18. Going from 18 to 3 is a scale factor of 1/6. Going from 24 times 1/6, this would be 4. If I were to set this up as a proportion, call this distance x, I could have said x is to 3 as 24 is to 18. And when you solve it, you get x is equal to 4. Here, AE is 3, AB is 2, BC is 6, and ED is 2x minus 3. We have proportional parts because we have parallel lines. These two go together, these two go together. So I could say 2x minus 3 is to 6 as 3 is to 2. Multiply both sides by 6, and I get 2x minus 3 is equal to 9. Add 3 to both sides, 2x is equal to 12, and divide both sides by 2, x is equal to 6. If the question said find ED, I would have to substitute this back in here. 2 times 6 minus 3 is equal to 9, is equal to ED. Yet another problem. And these are more exercises now than they are problems because we know how to do it as long as we set it up correctly. I'm not separating the triangles here. I don't have to because I know I have proportional parts. If I didn't, if I were asking for these parallel sides, then I would have to break apart the triangles to follow a good procedure. So here I can set up the proportion. X minus, X minus 3 is to 16 as X plus 5 is to 20. I'm going to multiply both sides I'm going to cross multiply. So I have 20 times X minus 3 is equal to 16 times X plus 5. I'll distribute 20X plus 60 is equal to 16X plus 80. I'm sorry, minus 60. And now you get 4X is equal to 140, or X is equal to 35. Then we come to this fellow. Now notice, if I'm looking at a triangle, say this one, I'm not going to look at the numbers on this line. I'm going to look at the numbers along this line and along this line. And if I want to find X, it matches up with the 4. X is to 4 as, here's two numbers, 3 is to 2. If I used U is to 3, that would not be giving me 3. If I did 3 is to 10, I'm not comparing apples to apples or oranges to oranges. U is to 3. U is to 3 as 3 is to 2. I could say M, but if I do these numbers, I would have to solve for them first. If I want to solve for this, it goes with the 2. M is to 2 as 10 is to 4. And do the same thing for N. N is to 3 as 10 is to 4. And here we have Y. Now Y matches up with this side, and this side goes along with the 5. So Y is to 5 as 2 is to 3. We also had in this lesson this exit ticket. And are they parallel? Well, let me ask you, are the parts that it divides it into proportional? If they are, then it's true. If not, then they're not. Good luck and success.